Hello everyone, it's Garith Modi, along with my friends Bihur Prashant Nayak and Jambala Premsai. Today we are presenting on industrial waste as coarse and fine aggregate or cement. Introduction to waste. Introduction to industrial waste. Industrial waste refers to byproducts and discarded materials generated by manufacturing processes and other industrial activities. This waste can include a wide range of materials from hazardous chemical and heavy metals to non-toxic solids and liquids. Proper management and disposal of industrial waste is crucial for protecting the environment and human health, as improper handling can lead to soil, water, and air pollution. Understanding the composition and characteristics of industrial waste is the first step in developing effective waste management strategies. Some common type of industrial waste includes metallic waste, chemical waste, electronic waste, and construction and demolition debris. Each type of waste requires special handling and treatment methods to minimize its environmental impact. Sustainable waste management. Sustainable waste management embraces the principles of circular economy, where the goal is to minimize waste and maximize the reuse and recycling of materials. This approach shifts away from the traditional linear take make waste model towards a more sustainable system that keeps resources in use for as long as possible, extracts the maximum value from them, and recovers and regenerates products and materials at the end of their service life. The waste hierarchy is a key framework for suitable waste management, emphasizing the priority order of waste prevention, minimizing reuse, recycle, recover, and disposal as the last resort. By prioritizing waste prevention and reuse, we can reduce the amount of waste generated, conserve natural resources, and minimize the environmental impact of waste disposal. Sustainable waste management also involves the adaptation of innovative technologies and processes such as advanced sorting and recycling system, waste to energy conversion, and development of new products and materials from waste streams. These technologies can help divert waste from landfills, reduce greenhouse gas emission, and create new economic opportunities in the circular economy. Now, I would like to call Vipu for further presentation.
Thank you, Garvit. Now, I will say about the types of industrial wastes. Industrial waste encompasses a wide range of material generated by various manufacturing processing activities. These can include hazardous substances like heavy metals, organic compounds, corrosive chemicals, and non-hazardous materials such as construction debris, plastic, paper, organic matter, etc. Some of the major categories of industrial waste are mining and mineral processing waste, which includes overburden tailing and slag from mining, quarrying and mineral extraction operations. Manufacturing waste. Factories good producing goods ranging from electronics to textile generates a diverse array of waste streams, including solvents, paints, sludge, metals, and savings. Chemical and petrochemical wastes, such as the production of fuels, plastic, and other chemicals, result in hazardous materials like spent catalysts, oily sludge, and acid tars. Power generation waste, such as coal-fired power plants, produce large volume of ash and slag, while nuclear facilities generate radioactive waste that require specialized handling and disposal. Construction and demolition waste. Building, renovation, and demolition activities generate enormous quantities of concrete, wood, metal, and other inert materials. Now, for the properties of industrial waste. Industrial waste as encompasses a diverse range of materials generated by manufacturing, processing, and other industrial activities. These wastes can exhibit a wide variety of physical, chemical, and environmental properties that are crucial to understand for the proper management and potential utilization. Characteristics such as particle size distribution, density, chemical composition, and leaching behaviors are important factors to consider when evaluating industrial waste as potential resource. The particle size of industrial waste can range from fine powder to large coarse aggregate, depending on the specific source and processing method. This has implications for the handling, transportation, and potential applications of the material. Density is another key property, as higher density wastes may be more suitable for use of construction aggregate, while lower density materials could be better suited for other applications like insulation or lightweight fillers. The chemical makeup of industrial waste is highly variable, and it also depends on the manufacturing process and raw materials used. Some wastes may contain hazardous substances that require special handling and disposal, while others may be relatively benign and suitable for beneficial reuse. The potential uses of industrial waste includes of construction materials, soil amendments, and energy recovery. In construction materials, one of the most promising users of industrial industrial waste is a replacement for traditional construction materials like sand, gravel, and cement. Many type of industrial waste such as coal ash, slag, poultry sand, which have properties that make them suitable for use in concrete, asphalt, and other construction applications. By incorporating these waste materials into building products, we can divert them from landfills, reduce the demand for virgin raw materials, and create more sustainable and eco-friendly construction solutions. Industrial waste can also be repurposed as soil amendments to improve the fertility and structure of agricultural and landscaping soil. Waste material like paper mill sludge, gypsum, and cement king dust can be added to soil to increase nutrient level and enhance water holding capacity and promote better plant growth. This not only divert waste from landfills but also helps to improve the health and productivity of the soil, supporting sustainable agriculture and landscaping practices. In energy recovery, which is another beneficial use of industrial waste, is for energy recovery. Certain type of waste such as municipal solid waste, biomass waste, and industrial sludge can be incinerated or processed through other thermal treatment technologies to generate heat and electricity. This not only reduces the volume of waste sent to landfills, but also produces a renewable source of energy, offsetting the need for fossil fuels and contributing to more circular and sustainable economy. Now, for further, my friend Prem will explain about fine and coarse aggregate replacement.
Thank you, Vibhu. We can replace fine aggregate. One of the promising applications of industrial waste is replacement of fine aggregate in concrete and other construction materials. Fine aggregate, typically small gravel or sand, are essential component of concrete that provide strength, workability, and density to the mixture. By utilizing industrial waste as a fine aggregate substitute, the construction industry can reduce its reliance on natural resources and divert waste from landfills. Industrial byproducts such as fly ash, blast furnace slag, and silica fumes have been extensively studied and found to be suitable replacement for traditional fine aggregate. Incorporating industrial waste as a fine aggregate not only reduces environmental footprint of construction but also prevent economic benefit. We can also replace coarse aggregate with industrial. One of the key application is production of concrete. By substituting a portion of traditional coarse aggregates such as gravel or crushed stones with industrial waste materials, concrete producers can reduce their reliance on virgin resources and create a more sustainable construction materials. Many industrial waste materials, when properly processed and incorporated into concrete, can enhance the durability and performance of the final product. For example, the use of steel flags such as a coarse aggregate can improve the concrete resistance to wear and tear, making it more suitable for heavy-duty applications like roads and bridges. Replacing the traditional coarse aggregate with industrial weight can also lead to significant cost saving for construction projects. The availability and often lower cost of these waste materials can also help the offset the expense associated with the sourcing and transporting virgin aggregates. By utilizing the waste material as a coarse aggregate, the overall environment impact of concrete productions can be greatly reduced. This includes decreased extraction of natural resources, reduce energy consumptions during the processing, and diversion of waste materials from landfills. We can also replace cement with industrial waste, which offers significant benefits in terms of sustainability and environmental impact by incorporating industrial byproducts such as fly ash, slag, and silica fumes. Some of the benefits of replacing cement with industrial are reducing CO2 emissions. Cement productions accounts for significant portion of global greenhouse gas emission. Using industrial waste as a cement substitute can significantly lower the carbon footprint of concrete and construction materials. Repurposing the industrial waste for cement production helps divert materials from landfills and incinerators, contributing to more circular economy and reducing the environmental burden of waste disposal. Many industrial waste materials, when used as a cement replacement, can enhance the durability and performance of concrete, leading to longer lasting infrastructure and reduced maintenance requirement. By embracing the use of industrial waste as a cement replacement, we can create more sustainable and environmental friendly construction materials that help to mitigate the impact of built environment. This approach not only reduces emission of waste but also present opportunities for innovative product development and cost saving construction industries. Now, my friend Bibu will explain how replacement of fine aggregate and coarse aggregate benefits the environment.
Thank you, Prem. Now, for the environmental benefits, reduce landfill burdens. By repurposing industrial waste as construction materials, we can significantly reduce the amount of waste sent to landfills. This not only conserves the valuable landfill space, but it also reduces the environmental impact which associates with landfill operations, such as greenhouse gas emission and contamination of soil and groundwater. Diverting industrial waste from landfills has cascading positive effects on the overall waste management system and helps to create a more sustainable circular economy. Conserve natural resources. Utilizing industrial waste as substitute for virgin raw materials such as sand, cement, gravel helps to conserve our finite natural resource. Mining and extraction of these raw materials can be energy intensive and disrupt to the environment. By replacing them with recycled industrial waste, we can reduce the need for new extractions, which in turn preserves our natural landscapes, reduces habitat destruction, and minimize the carbon footprint associated with the production. Reduce emissions. The manufacturing process for many construction materials, such as cement, can have a significant carbon footprint. By incorporating industrial waste into these materials, we can easily reduce the overall energy consumption and greenhouse gas emission associated with their productions. This not only helps to mitigate climate change, but it also improves the air quality in the surrounding communities. Now, for environment impact and sustainability, reduce environmental footprint, which utilizing industrial waste as replacement for traditional construction materials such as fine and coarse aggregate or cement can significantly reduce the environmental impact of the construction industry. By diverting wastes from landfills and repurposing it, we can minimize the extraction and consumption of natural resources, leading to a smaller carbon footprint. Circular economy principles. The integration of industrial waste into construction material align with the principle of circular economy, which, where waste is viewed as a valuable resource rather than something to be discarded. By closing the loop and using industrial byproducts, we can create a more efficient and environmental conscious economic system, reducing the reliance on virgin material and foster a more sustainable future. Reduce landfill burden. Diverting industrial waste from landfill and incorporating it with construction materials can ease the burden on landfill sites, which are often overburdened and contributed to the environmental pollution. By repurposing these waste streams, we can reduce the need for new landfill space and minimize the risk associated with improper waste disposal. Long-term sustainability. The use of industrial waste in construction materials not only provides immediate environmental benefits, but also contributes to long-term sustainability. By developing innovative solutions that integrate waste streams, we can build a more resilient and durable infrastructure, reducing the need for frequent repairs and replacement. And this approach helps to conserve natural resources and ensures that the built environment remains sustainable for generations to come. Now, my friend Garvit will explain the utilization of industrial waste as alternative building material.
Thank you, Vipul. As global demand for construction materials continues to rise, there is an increasing need to explore alternative and sustainable resources on promising avenue in the utilization of industrial waste as fine and coarse aggregate or cement replacements. This approach not only diverts waste from landfills but also reduces the environment impact of traditional construction materials production. However, the successful integration of industrial waste into building materials requires careful consideration of various technical, economical, and environmental factors. Testing and experiments on industrial waste. Material characteristics. Through characterization of physical, chemical, and mineralogical properties of industrial waste is a crucial evaluation their suitability as alternative building materials. This includes tests to determine particle size, distribution, density waste, water absorption, and any potential contaminants or hazardous substances. Performance evaluation. Extensive laboratory testing is required to assess the performance of industrial waste-based building materials, such as their compressive strength, fractional strength, durability, and resistance to weathering. This data is essential for determining the appropriate applications and ensuring compliance with relevant building codes and standards. Environmental impact assessment. It is critical to evaluate the environmental impact of using industrial waste in construction, including their potential to release harmful substances, their carbon footprints, and their overall sustainability compared to traditional materials. This assessment helps to identify any necessary mitigations measures and ensure the long-term viability of the approach. Results and findings. Promising performances. Research has shown that various industrial waste such as mining, tailing, steel slag, and fly ash can be successfully incorporated into building materials, often matching, even exceeding the performance of traditional aggregates and cements. Economic benefits. The use of industrial waste as construction materials can provide significant cost savings by reducing the need of virgin raw materials and disposal costs. Sustainability advantages. Utilizing industrial waste in construction helps to divert material from landfills, reducing the environmental burden associated with waste disposal. Additionally, the reduced energy and resources consumption in the production of these alternative materials can lead to a lower carbon footprints compared to traditional construction methods. Challenges and limitations. While the use of industrial waste in construction shows great potential, there are also challenges such as ensuring consistent quality, addressing any potential regulatory hurdles, and overcoming any resistance to the adoption of new materials in the construction industry. Now I'd like to call my friend Prem for future directions and initial opportunities of industrial waste.
Weakened diversification of waste resources, expanding the range of industrial waste streams that can be utilized in construction, such as agricultural waste and electronic waste. Continuing the research to optimize the mix design and proportion of industrial waste-based building materials will help to enhance their performance, durability, and cost effectiveness. Exploring a new innovative applications for industrial waste-based, such as in 3D printing, geopolymers, and other emerging constructions. To finally conclude our topic, the utilization of industrial waste as alternative building material represents a promising approach to addressing the growing demand for construction materials. Achieving its full potential of the industrial waste-based construction materials will require continued collaboration between researchers, policymakers, industry stakeholders, and broader public. As the construction industry evolves to meet the challenges of sustainable and resource scarcity, the use of industrial waste as alternative building material represents a significant shift in the way we think about and utilize materials. By embracing this paradigm shift, we can unlock a more sustainable and resilient future to build environment. Thank you.